it's not easy. Okay, those are not easy problems. My first problem I want to briefly discuss is following. Okay, suppose we are given expressions like that. So 1, 3, 5, 7, 8, 9, 11, 13, 15, 17, 19. Okay, the bottom part is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now, if you can express, okay, I believe that we can express it as 2 to certain power, q, and here's p. P and q are positive integers. Okay, can we find, find the p and the q? Okay, let's try this. It's surprise, right? In the denominator, there's only fact after simplifying. There is only fact of 2. There's no other integers. Now, is this always true or not? Right? So the quick way to solve the problem, we don't know, right? It's always true or not. Okay, p and q are positive integers, and p is, p is, we want, it's not, in general, it's not true. So we want to put addition condition if, okay, p, okay, and the q are positive integer, okay, and the p is also other number. So all we needed to do is find a prime factorization, and you simplify it. Okay, simplify the denominator and the numerator, and some common factor should be removed. Okay, and then you also ask the question: is this always true or not? In general, we don't know, right? You can, so from this specific problem, the next step, you can always think about, can I increase both sides, numerator and denominator, all the way to 99 and 100 at the bottom. Is it still true or not? So I don't know. So let's focus on this problem. So here, first of all, you have 3, 5, 7, 9, 3 squared, 11, 13. Most of them are prime numbers, right? 7, 10, 19. The denominator is 2. 2 squared, 2 times 3, right? 2 cubed, and 2 times 5, 2 squared times 3, and 2 times 7. And then, then 2 to the 4th power, then 2 times 3 squared, right? And then 2 squared times 5. So as long as you can get rid of 3, 5, and then you only get a factor of, so you only, then you get only factor of 2, surprise, right? Now 7, and this one, and this one, okay? Let's see how many 3s there are down there. Okay, 1, 3, and you have a 4 factor of 3, right? So you have 1, 2, 3, great. So 5 is also there. You should have 2 5s. Yes, we have 2 5s. Then cancel, 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 cancel. How about 7? Yes, I do have a 7. Cancel. Okay. Okay. So what do you get? Okay. You will get, okay, the numerator is 11 times 13 times 17 times 19. The denominator is 2 to the power 1, 2, 1, it's a 1 plus 2 plus 1 plus 3 plus 1 plus 2 plus 1 plus 4 plus 1 plus 2. Okay, total is 18. Okay, so you get this. Okay. Now, a good student, when you see a problem like that, okay, and you will think about, is this just lucky, or we have this information, this phenomenon? Is always true if the top is a product of consecutive odd numbers, the bottom part is product of consecutive even numbers. Okay, all right, and yeah, that's true, right? So maybe you can find the general theory in number theory. Okay, general theorems. So you can try think about this problem. Yes. Okay. When you look at the yeah, this is a very specific problem, right? Now, how about if I add a 21 and the 22, right? And you try, suppose if I have a 21 here, 22 here, it's okay. We still can only get a factor of 2 in the denominator. And it looks like, yes, because 22 is 2 times 11, and I already have 11 there, right? Cancel out. Then you will say, how about 24, right? 24, right? And the 20 here is 23, 24, and 24 is a 2 cube and 3, and then you say, oh, is it true or not, right? Okay. Then you search for the numerator, you find out there's no factor of 3 there. Okay. Then you stop. So the largest number you can have, yeah, you stop here, 21 over 22. Okay, right? Because if it's 24 all the way to 24, and then you get a factor of 3. And then there's no factor of 3. Well, yes, there is a factor of 3. Okay, sorry, that's my mistake. And so because 21 is a 3 times 7. So the 3 still cancelled out. Okay, so keep it going, right? I don't know how far you can go. Okay, and I'm surprised. Yeah, there's a factor of 3 create, right? Yeah, 26 is going to be 13 times 2. So there's a 13 here, and the 28. 28, there'll be 4 squared times 7, but there's also 7 factor already there. Okay, factor of 7. So I think this problem is always true, right? But you have to prove it. Okay, you have to look at some examples, and then you can state the general theorem. Okay, but this is a good example, and they also give you some, interesting questions. You can continue work on that. Okay. So next problem is that there are 2 values of x such that x minus 2018 over x minus 2019 is going to be 1 over 6. Okay. Find the find the difference of those 2 numbers. Find the difference, positive difference. Right? You don't know which one is that, right? So find positive difference of these 2 values. Okay. All right. So I wanted to try to see if we can do, and then then if we are teaching, maybe you can create another problem, because this is a problem was given in 2018, 2019, right? And how about 2000 and 2021, right? 2020 and 2021. So that's another question you can try. Okay, so all we needed to know is if a value of x is going to be some a, right? A is a positive number. Then this is equivalent to say that x is going to be plus or minus a. Okay. So I can just work on the general case, right? I want to, here's x, maybe because I want to generalize it to more general case, right? So this n, how about this, n plus 1? N could be 2018, 2020, right? And this is going to be plus minus 1 over p. And p could be 6, 7. So I want to choose a specific integer so that this is true. So I get two solutions, right? And maybe I can get a general formula. Then all I need is just change the numbers, right? So this is a, this is a slightly more general than the above equation. Okay, if I put the absolute value here, then this is always positive, and then this equivalent to the following, the following equation x1. Okay, let's solve this first. Okay, so this is the first equation. I get p x minus n equals x minus n plus 1. And then I solve for here p x, and that's a pn. Okay, so what I get here is I move this to p minus 1x. Here's a pn minus n plus 1. Okay, so my first solution is okay, that's the first solution I got, right? So my second solution is x minus n over x minus n plus 1 is negative 1 over p, right? Yeah, let's find out. Okay, so this is going to be p x minus n negative x minus n plus 1. So it'll be negative x plus n plus 1, right? But here, this side is px minus pn, right? Right, then I move this term to the left and the other term to the right. I get p plus 1, and here's a pn plus n plus 1. Okay, so finally, x2 is going to be pn plus n plus 1 and divided by p plus 1. Okay, so actually you can always get very general, then you take the difference, x, I don't know which one is smaller. It looks like the second one is larger. First one is smaller. Let's say x1 minus x2. Okay, then you simplify it. So you get a very general formula. You don't need to work on specific numbers. Okay, minus. Now we do not have a common denominator, right? So this is the weak part. This is the bad part, but it's okay. You can always multiply them out and simplify. Okay, so let's continue. Okay, this is n plus 1 and minus 1. This is n minus 1, pn plus n plus 1. And here's n plus 1, and this one is a pn minus n minus 1, right? So let's multiply this out. Okay, you should be able to get the pretty simple formula. Okay, so how do I do that? I multiply p minus 1 times p, then times n, right? Then the other one is a p minus 1 and n plus 1, right? And here, p plus 1 times p. Okay, then have a minus minus plus. Okay, so now it's easier to do this computation, okay? So what you get here is p and p is the same. So p minus 1 minus p plus 1 is actually negative 2 pn, okay? And how about the other two terms? P minus 1, p plus 1, add them together, it's 2p, right? Then I continue to simplify it. I have a 2pn, right? You were surprised. So this 2pn plus 2p. 2p and 2p can cancel out. Wow, what did you discover? What you discover is independent of n. I did not know that, right? If you try to do the general case, and this is independent of n, okay? So even this year I changed the problem, right? So if I ask you to look at 2020 minus x 2021, okay? It's 1/6. The answer is still the same answer, okay? Okay, so the answer is x2 minus x1 is going to be 2 times 6, 6 squared minus 1, right? So that was 12, 35. You see the same result. So next year, if we change the problem and you end up with the same answer, see? So we did not do that even at the very beginning. A surprise, right? After you simplify it, and you get a number only depends on p, right? Yeah, when p equals 6. So what I'm trying to ask you to do is, you see, this is build up a good habit, to become politician, become a scientist or whatever, even doctors. So when you see a special case, you will ask yourself, how about, you should be very curious about it, after you solve the problem, not just stay on this one. And you think about, is that true in general or slightly more general, okay? One step further. And then just like what I did here, you see, I don't specify the numbers because I see the difference between 2018 and 2019 is only, those are two consecutive numbers. So I just replace 2018 by n and then replace 6 by p. Then I try to derive general. Then I find, oh, that's really good. You see? And it's a small things, but sometimes you discover new stuff, okay, in mathematics. But it's the same idea even in medical science, in biology and chemistry. So when you see observer, when you do some experiment, this already routine experiment, it's a very specific, and you find a phenomenon. You don't just stay there. You have to think about, is there maybe, you probably discover something different, okay? Okay, so this is very important, not only just to learn the knowledge in mathematics, you see, it's not just, oh, I understand how to solve some problems, that's it. And then you were thinking, that would never be used maybe in my whole life, right? Yes, it's possible, this equation, you never would be see that and never be used that, it never be used in your whole life. It's possible, but the training, the way you think, okay, it's a very important, okay? All right, so our next problem is find the positive integer s satisfying 6 less than equal to s less than equal to 36, and s times 42 minus s is less than 297, okay? And yeah, we're trying to find all the solutions if possible, okay? Now, this is a simple inequality, right? No problem. The only challenging part is this. Okay. Only challenging part is this. Okay, how do we solve this problem? Okay, I'll let you to think about, okay, if you haven't seen this type of problem before. Okay, how to solve this inequality. Okay, to get some general idea, right? Okay, before I show you to solve this problem, let's think about the general function. Okay, f of x equals ax squared. This is a quadratic function, bx plus c. A is not going to be 0, right? Okay, now if we draw the graph, okay, so the first case, if a is negative, the graph of this function will be a parabola, okay, open downward. Okay, then there's a two possibly there's two solutions. This is the general case. Sometimes there's no solution. Okay, it's parabola like that and no intersection. Okay. Okay. Right, and that's two cases here. No intersection. Here's the intersection, and another case maybe only one intersection. That's possible. Okay. So if I ask you to, this is y equals ax squared plus bx plus c. So if I ask you to determine the x, the inequality, right? And you will see that the picture on the right-hand side is no solution. But if there are two roots, x1, x2, what kind of x satisfies this inequality? So that means y should be negative. So this is equivalent to saying that from the picture, x is either should be less than x1 or x is greater than x2. Because only when x is here, the value, the y value is going to be negative, right? So that's why you can, yeah, it's when a is negative. I just give you one example, okay? And here, in this case, no solution, ax squared plus bx plus c less than 0. No solution. In this case, any x would be true because it's always negative. It's below the x-axis, okay? So that's two cases here, okay? And when a is positive, this is when a is positive, this is a parabola opens upward, okay? And there's also two cases here almost. Another one is like that, no intersection, okay? And if you still want to solve this inequality, what do you get, right? And x must be between x1 and x2 because only for those x's the corresponding y value is negative, right? Because an arbitrary point here, x is a corresponding x, but the y is determined by, this y is determined by ax squared plus bx plus c because that's called graph, right? Otherwise, it's not the graph of this function. So it's equivalent to saying that x is greater than x1 less than x2. But in this case, no intersection with x-axis. So it's always positive. So if you want to solve this inequality, no solution, okay? Because for any x, this is a positive. So the function is positive. Okay, so there's no solution. Okay, this is in this case. All right, so this is my it's a review on the quadratic functions graph. So how about this inequality? Okay, can you solve it? Okay, yeah, please go ahead and do it. All right. So anyone has answers? Yeah. So let's rewrite this equation, right? S42 minus S times S42 minus a minus 297 is less than 0, right? So if you write down the details, is 42S minus S squared minus, you see, that is the inequality, right? So you get S squared plus 42S minus 297 equation. So I needed to find the two roots of that. So negative x squared plus 42 minus 297. You can take sign negative sign out if you don't like. Okay. So you can use the quadratic formula. However, 297 is 9 times 33. Okay. So if you can see that, that'd be s minus 9, s minus 33. S minus 9, S minus 33. So if this is going to be less than 0, what are you going to do? Because this is a parabola, opens downward, right? Okay. And here is a 9, here is a 33. So clearly S should be less than 9 or S should be greater than 33. Okay, S should be less than 9. But on the other hand, we already know our other hand, right? On the other hand, S should be greater than equal to 6, less than equal to 36. So how many solutions you get, right? So S should be equal to 6, 7, 8. And then 34, 35, 36. Okay. Grant, now your answer should be just a list of the numbers. Don't put them together. It's not like a pair of the numbers. Okay. 6, 7, 8, and 36, 35. Yeah. 6 and 36 is not combined. It's not like a point in the plane. And that answer is incorrect if you like in this form. I just want to write down the value for S. Okay. Okay. So that's it. So this problem, doing this problem, we have to review the inequalities, quadratic inequalities. We call it quadratic inequalities. If you know the graph of quadratic inequalities, a parabola, then you can easily solve the problem. Okay. Okay. Our next problem is from ShenMathClass 2. Okay. We assume that the following expression represents a rational number. What is the smallest possible n? If 3 over 1, 4 over 2, 5 over 3, similar to the first problem, is a rational number. Okay, what is the smallest possible value of n? Okay. Yeah, this is not a difficult problem. Yeah, please do it. Now, Richard, it's not 2. Okay, 2 cannot be. If it's 2, 3 times 4 divided by 2. No, it's not a rational number. It's an irrational number. Right? In general, okay, if you cannot get rid of the radical, it is irrational number. Okay, irrational number. Okay, so the general fact is square root of m is irrational if m is not a square of a fraction. If you cannot get rid of the radical, in other words, right? So such as like 7/2 is irrational, right? Okay. But 16/9, which is it's a 4/3 square, it's a 4/3. This is irrational. Okay. Got it? Yeah, let's go back to this problem. Yeah, we're doing this kind of, the same time we go reviews what we learned before, right? Anyone have answers? William? 天乐良? Eric? Erica? Yeah, we have more boys than the girls in this class. Okay. Have you worked out? All right. Okay, let's take a look at this, right? You have to simplify, otherwise it's not. Come on, right? Divide by 1, 2, 3, all the way to n. Actually, you can simplify. How? Well, you see, remember this is n plus 1. So this part and that part cancel out. So all you get is only get n plus 1, n plus 2, n divided by 2. Come on. So this is this is simplified. As long as if if n is let's say greater than equals 3, okay? If n equals 2 doesn't work, I already said, we try to try it, n equals 2 is not working. So you try n greater than equals 3. If n greater than equals 3, the numerator, you will have a 3 begin with 3 all the way, to n. If n equals 3, that's only 3 then. If n equals 4, it's 3 times 4, okay? So for this one, when it's going to be integer, okay? When it's going to be a rational number, so you have to make sure this is a perfect, actually it's going to be a perfect square, okay? I want to make sure it's a perfect square, some irrational number, okay? And you try, just try, and you can see when it's going to be perfect square, right? So you try, you let n equals 3, n equals 4, n equals 5, n equals 6, and finally, when n equals 7, you get 8 times 9 divided by 2, which is 4 times 9, which is going to be 36, which is 6 squared. Got it? So quick observation. So the answer is, yeah, because all of them does not work. So the answer is n equals 7. Got it? Great. So the first key step is to simplify. The lots of terms can be canceled out. Okay. Yeah, simplified. Yeah, let's try, let's do a simple problem here. This is a really simple problem, okay? We know that the product of two consecutive integers, positive. If I remove the positive, then you're going to have two solutions. Is 306. Okay. What is the sum? Okay. Now, so you read the question carefully. Okay. If I remove this, then you possibly have two solutions, and you need to be very careful about this. Okay. So read the question. So the product of two numbers, okay, two consecutive positive numbers. Yeah. So you got 35. Grant did very fast. Okay. So all you have to do is look at 306. Clearly, this is divided by 3. And then try, right? Divide by 3. Factoring, this is a procedure, right? And it's even number also. Okay. So first of all, it's an even number. And the 300, right? Divided by 2. You take it out. This is going to be 153 times 2. And the 153, add all the digits together, it's going to be what? It's going to be 9. So it's divisible by 9. So then it's 9 times 17, right? Times 2. So that's the whole process. So now you get, this must be a product of two consecutive integers. So 17 times 18. So the answer is 17 plus 18 equals 35. So you have, the reason I ask you to read the question carefully is, so if this positive is, the word is removed, right? Then there are two solutions. Okay, the reason is 306, first of all, this is a product of two positive integers, right? But this can be also as negative 18 times negative 17. Okay, so it's also, right, it's the same product. And the negative 18, negative 17 are consecutive integers. So the answer will be, another solution will be negative 35. Okay. Okay. Our next problem is, what is the smallest positive integer n such that 2n is a perfect square and 3n is a perfect cube? Wow, the cube is a little bit difficult to think about. Okay. My hint is you have to write them in this form, and you try to determine P and Q, okay, by divisibility. Okay. That's my hint. Okay. So you get P square and the cube, right? So this is that's only assumption. So what do you get? You will get, okay, right? And so how does that relate to the P square and the cube, right? So we know that 6n, right, is going to be 3p squared. That'll be 2. Yeah, this is identity you have to use. Okay. So 6n is a 3. How do you compare them, right? The only thing in common is n. right? You can say that p square, p square, you can say that p square over 2 should be equal to cube over 3. So that's n, right? So then you have a 3p squared. All right, so from here, what you can tell? Well, you can tell that q is divisible by 3, right? And the p is divisible by 2 because 3p squared is divisible by 2 because it's on the right hand side it is 2 times some integer, so it's divided by 2. Okay, so then you can write p equals 2x, q equals 3y. Okay, let's put this. Then you plug into the above equation. You simplify it. You simplify it step by step, right? Yeah. So 3 2x squared and 2 3y cubed. Okay, let's simplify it. It's a 3 and here's a 4 x squared and here's 2 and the 3 cubed y cubed. Let's simplify it. So I got 2x squared equals 9y cubed. Wow. So that means x must contain a factor of 3. Y must be contain a factor of 2. Right? So that implies x must be contain factor of 3. So 3, let's call 3a. Y is going to be 2b. Yeah. And then you put them again. So you get 2a squared and then 2b cubed. Okay, let's simplify. So I get 9a squared is 9 and the 3 cubed b cubed. Yeah, we okay now. 9 canceled out. A squared equals 2 squared b cubed. But so we try to choose a smallest possible value for a and b, okay, such that this equation, yeah, find the smallest possible values of a and b, okay, such that the above equality hold. And that clearly, smallest possible value for b is 1, right? And a is going to be 2. A cannot be 1. A is greater than 2. A is greater than 1, definitely. So those are the solutions. Then you go back, step by step, you go back. So x, you just need the x, right? X is going to be 3a. Is going to be 3 times 2 to 6. Okay, once I get an x, then I get p. Okay, p is going to be 2x, so it's 12. Once I get a p, and I can get n because 2n is going to be n is going to be p squared over 2. So n is going to be p squared over 2. So so 12 squared over 2. That's a 72. Okay. So just step by step, you cannot guess and try because once you get 72, how do you prove this is the smallest integer, right? Okay, I have a question to Grant. How did you get 72 so quickly? Can you give me, is your ideas different from mine or just a similar idea, but you did fast?
What I did was, since I knew it had to be divisible by 2 and 3, so it had to be something related to 6. So then I just tried 6 cubed was 216, and then divided by that by 3, which is 72, and then it worked.
Okay. Yeah, probably. Yeah, it's similar idea, but it's a little shortcut here. Okay, so basically, you look at both sides, what kind of factor should be, there, and then you find the smallest. Okay. This one is just a pretty standard method, just step by step. You look at both sides of the equation, right? And finally, you choose a smallest value for n. Our next problem is we're trying to find two integers between 1 and 100, okay? Such that for each, okay, if you divide by 4, the remainder is going to be 3. Okay. Second, if you divide by 3, the remainder is 1. Right? And if you divide by 5, the remainder is also 1. Okay. So there should be some integers. Looks like only one integer, only two integers satisfy this inequality. What is the first condition? Find the two integers between 1 and 100 satisfy. Yeah, we don't know. It looks like, right? There are only two integers, because if there are three integers satisfy these three conditions, then and that's problem wrong, right? Okay. There are multiple pairs of solutions. Okay, right? Yeah, if you have three integers set transition equality, if I ask you to find a pair of integers set between 1 and 6, then you have several pairs of them. All right, so you try. Okay, we still have a time. How can we start with this kind of problems? Okay, there's a tricky here, to begin with. Problem like that usually, on the test, I don't know. This is a MathClass problem, either somehow from a sprint one, from a target run. Okay, if it's target run problem, you're given 3 minutes, I believe that. Otherwise, you're given much less time. Yeah, 1 minute. All right. My hint is you have to begin with these two conditions. You cannot use three conditions immediately together. So a number divisible by, this is a number, okay, that's a number, okay, let's call it a number. This number, if you divide by 3, if you divide by 3, the remainder is 1. If you divide by 5, remainder is 1. So that means that number minus 1 is divisible by 3 and 5. That's my hint, right? So Erica, you have answer. No, you only find the 1. There should be 2. Right? 31 is one of the integers, but I'm asking to find the 2 integers satisfy this requirement. Okay. So n minus 1 is divisible by 3 and 5. So that's why n minus 1 should be equal to 15 times q. So n equals 15 plus 1. And the Q is integer, right? Q could be 1, 2, all the way. So if you list them, N is going to be 16. 30 plus 1 is 31. 46 and 61. 76, 91. Okay? Otherwise, it's larger than 100. But we're looking for another one, which when you divide by 4, the remaining 3. Divide by 4, the remaining 3. And this is a number, and that is a number. There were two numbers, not a 61, 91. There we go, 91. Yeah, 91, not 61. 61 divided by 4. The remainder is not going to be 3. Okay, I think so. This is a remainder is going to be, it's going to be 1. Yes, oops, I couldn't say that. That's right, it's 91. So you only have a few numbers to check. Okay, this is the idea. Okay, so the key point, the key step is to use the second and third condition to get a finite many numbers satisfying those two conditions. Then you check one by one quickly. Yeah, whether this is a, whether those numbers satisfy the first condition, right? Yeah, and Erica, when you see a problem, read the question first. Don't just put 33, 31 there, right? That I said already there are two integers there, so at least you find another one. Okay. All right, about the pair numbers, okay, we have a twin primes are prime numbers, okay? That's a definition that differ by 2, okay? So we know that given that A, B are the greatest twin primes with A less than S100. Okay, so can we find out? Yeah, find them, okay? Find the A and the B. Okay. So that twin prime numbers, okay? So you have to know, this is a stupid problem, you have to know lots of prime numbers less than 100, okay? If you memorize, I begin with 97, we're trying to, because we're trying to find the greatest twin prime numbers. So 97 is a prime number, okay? Then what is the next one? 95, 96, 95, 94, 91, they're not prime numbers until 89. So there's a huge gap here, okay? Then quickly search, the next one will be 83, then 79, then 73, and then 71. Okay, we find it. So this is a twin prime number, okay? If you remember that before, then you can write down the answer quickly. Otherwise, you have to begin with the largest prime number, less than 100. Then you try to solve it. Okay. Okay. So our last number, our last question is, okay, this is a little bit challenging problem, and we have two non-empty sets of numbers. Okay, 1, 2, 3, 4, 5, 6, 6, 7. This is going to be separate into two groups, okay? Two sets, okay? The numbers in A are multiplied to get, well, what I'm going to say is, A is going to be the product of the numbers in A. Okay, B is going to be product of numbers in B. Okay. Okay, then the larger of the two numbers write down. Is written down. So question is, what is the smallest number you can get using this procedure? Okay. All right. So what does that mean? Just take a look at it, right? You can separate them. Okay, A is 1, 2, 3, 4, right? 5. B can be 6 and 7. Then you multiply this out. In this case, the product of those numbers, right? 2 times 3 times 4 times 5 is 120, and B is 42. So so you write down, 120 is a number. Okay. 120 is a number. Okay. Okay. 120 is a number. Okay. And then you try a different number. You want to make this number smaller, right? That's the first one. And then you look at another case. 1, 2, 3, 4, right? And in that case is, right? And then B is going to be large, 5, 6, 7, right? Five, 6, 7. So what do you get, right? So you get 5 times 6 times 7. So you get to 100. No, you get an even much larger number. So it's not easy to figure it out quickly. So then you want to find the smallest one. Remember, you have a list of all of them, right? So what is a quick way to determine? So let's see. To solve this problem, I don't have much time left. So A times B is a product of all those numbers, right? Which is 5,440. Okay. We can assume that A is always assume, that there's an equal position. A is less than B. Okay. We assume that, right? Then you write down the number B, and you want to make sure what is the smallest value. Then write down B, right? And you want to find the smallest possible value for B. That's it, right? So what you do is 5,040 is less than equal to, because it's going to be A times B, so it's less than equal to B squared, right? And then you can get the smallest possible value for B, for such B, right? So B is going to be, B is going to be the square root of this less than equal to B. So this is about 70.99, okay, almost 71. So the smallest possible value for B is in general, okay, we don't know we can make it, okay, and we find out 71 is a prime number, right? And but the next number you can get is 72. 72 is 2 cubed and yeah, 2 gives 3 cubed, right? 3 squared. Okay, it's going to be 3 times 4 times 6. So this is from the list. Okay, this is from the list. Okay, then you can say that, okay, let's say A is going to be 1, 2, 5, 7. B is going to be 3, 4, 6. Okay, and this is the smallest number you can get. Okay, so 72 is the smallest number you can get. Okay, when you multiply this out, right? What is the product? What is the product? This 2 times 5 times 7. This is a 70, and this is a 72. So when you choose these two sets, okay, then the larger number you get is 72. Okay, so yeah, if this is n, then 72 is written down. Okay, it's written, right? You choose a larger number, but this is 72 is the smallest number you can get. That's all other other separations always gives you a larger number than 72. Okay, so this is a kind of analysis you can you can get. Okay, it's not, yeah, 72 is a number you're looking for. Okay, so sorry, it's over time, and that's it. Okay, now you will get the homework assignment, and please, yeah,